Class, good afternoon. Now, today I will tell you the very important concept, the concept of transitivity. That means when the relation is said to be transitive. Now, class, unfortunately in NCRT things are not given fully. What I will tell you here, I will tell you the correct and concrete explanation for transitivity. So, a relation R in set A is said to be transitive if AB belongs to R, BC belongs to R, implies AC belongs to R. And if AB belongs to R, BC belongs to R, and AC doesn't belongs to R, it's non-transitive. Now, in NCRT, you have just these two definitions, but to make the definitions further, I have to tell you the rest of the forms also. Now, a relation R is transitive if AB belongs to R, BC doesn't belongs to R, implies AC doesn't belongs to R, or AB belongs to R, BC doesn't belongs to R, implies AC belongs to R. So, in transitivity, even if you have first case, third case, fourth case, relation is transitive. Whereas for second case, it's not transitive. Now, I will support this with many examples today. Take, say, X as 1, 2, 3. Now, relation R is a subset of X cross X, as you know. Now, I define R as, say, 1, 1, 1, 2, 2, 1. So you will see here AB is 1, 2, BC is 2, 1, and AC is 1, 1. So A is 1, B is 2, C is 1. So 1, 2 belongs to R, 2, 1 belongs to R, so 1, 1 belongs to R. Let us take R1 another set as, say, 1, 2, 2, 3, 1, 3, 2, 3, 2, 3 I have written, 3, 1, that's it. Now, 1, 2 and 2, 3 gives 1, 3 is in R, but 2, 3 and 3, 1 is in R, 2, 1 is not in R, so R1, so it's not transitive. So you can write that 2, 3 belongs to R1, 3, 1 belongs to R1, 2, 3 belongs to R1, 3, 1 belongs to R1, but 2, 1 doesn't belongs to R1. So R1 is not transitive. In the same way, class, if I have taken X as 1, 3, I have taken X as 1, 2, 3, and I define R3 as just 1, 2 only. Now, this R3 is transitive as 1, 2 belongs to R3, 2, 1, 2, 2, 2, 3 doesn't belongs to R3. So 1, 1, 1, 2, 1, 3 also doesn't belongs to R3. So R3 is transitive. Class, please make it very clear regarding this, that is this clear to you or not? Now, I defined R4 as 1, 2, 1, 3. Now AB is 1 2, AC is 1 3. So AB belongs to R4, AC belongs to R4. You have taken A is 1, B is 2, C is 3. So R4 is transitive. So you have this result, reflexivity and transitivity. Now another example, I take R5 set as, say, 1 1, 2 2, 3 3. Now R5 is reflexive, R5 is symmetric, and this R5 is transitive also. The reason being 1 1 belongs to R5. So here A is 1, B is 1. Also BC R5, that is B is 1, C is 1. So what is AC? AC is again 1 1, that belongs to R5. So R5 is transitive. Now let me take some more definition once again to make you very clear how to see transitivity. Define, say, X as 1 2. I define R5 as, say, 2 1. Is R5 transitive? Yes, R5 is transitive as it is transitive. As 2 1 is in R5, so A is 2, B is 1. Now, even if you take 1 1, even if you take 1 2, they are not in R5. Now here B is 1, C is 1. Here B is 1, C is 2. But what is AC? AC again comes to 2 1. So that is in R5. So R5 is transitive. Just see to it. Now, in the same way, if I take R6 as, say, 1 2 and 1 1. Now AB is 1 1, that belongs to R6. BC is 1 2, that belongs to R6. So what will be AC? A is 1, C is 2. So AC is 1 2, that again belongs to R6. So R6 is transitive. Please see to it. Now, last example, take X as, say, 1 2 3. I define R7 as 1 2, 2 1, 1 1, 1 3, 3 3. Now this is transitive as 1 2 is in R7, 2 1 is in R7. This means 1 1 is in R7. Also 1 3 is in R7, 3 3 is in R7. So 1 3 is in R7. So R7 is transitive. Now I will take up some problems where you have the description of the relation and you have to show the steps accordingly. Now define a relation R8 on reals as R8 equals to set of all those y such that x equals to y. Show that R8 is an equivalence relation. Now solution. See, you have here many infinite numbers 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and so on. Rather, the real numbers is there, so you can have in 0.5, 0.5, 0.6, 0.6, and many. Else you can make it naturals also. So, as x equals to x is always equals to x. So, x comma x belongs to R8. So, R8 is reflexive. Now, as x equals to y implies y equals to x. So, xy belongs to R8 implies yx belongs to R8. So, R8 is symmetric. Also, x equals to y and y equals to z. Obviously, xyz belongs to the naturals. xyz belongs to n. This means that x equals to n. So you have xy belongs to R8, yz belongs to R8. This means xz belongs to R8. So R8 is transitive. Now R8 is reflexive, R8 is symmetric, R8 is transitive, so R8 is an equivalence relation. Now, after this, I will try to do some practical models on this relations functions so that you can start with your practical files. I will post the practicals file schedule here only. Class, thank you, and I will post more questions for your practice and doubts. Thank you very much.